Determine the force in members DC, HI, and JI of the truss. State if the members are in tension or in compression. Now this one, as the book already illustrated, you can't cut through here and only cut through 3 members. And we can only solve for 3 unknowns at once. So what we're going to do is we're going to cut it twice, and with the 2 cuts we have 2 different objects, therefore we have 6 unknowns, or 6 equations. We can solve for 6 unknowns, and we have 1, 2, 3, 4, 5, 6 things we're going to cut through, so we could solve for all 6. So let's start with the cut they've demonstrated here at SS. So if I redraw that over here, okay, here are our unknowns, and this is the point H. Now if I sum this one about H, I eliminate this, and this. So I can solve for this, we'll call it FDC. We can solve for that one directly. So if we sum the forces in the, or sum the moments about H, we get 1200 times this distance, which is 9, minus FDC times this distance, which is 12, minus 16 times this distance, which is 21. 6 plus 6 plus 9, and that equals 0. So solving this, FDC equals 1900. Negative 1900. So next let's sum the forces. If we sum the forces in the X, now we solved for one of these, so if we do this second cut here, we could probably solve that one now because we have this one. That would leave only 3 unknowns. So let's go ahead and do that. So the second cut here looks like this. With unknowns. Where this one is 1900. Okay. Let's start out by, so we want to solve for these 3. If I sum the moments about J, I can solve for FHI directly. So if we sum the moments about, this is the point J, I get 1200 times this distance, which is 15, plus FHI times this distance, which is 6 plus or minus 1900 times 6 minus 1600 times that distance, which is 15. That equals 0. So we can solve for FHI. And that equals 900 down. Now all we have left is sum of the forces in the x and sum of the forces in the y. So if we sum the forces in the x, we have Ji and Jc. Now in the x we have Fji in the x negative plus Fjc in the x, and there's nothing else, so that equals 0. So therefore Fji in the x equals Fjc in the x, and because they have the same ratio of horizontal to vertical, therefore Fji equals Fjc. So let's sum the forces in the y. Negative 1200, negative 900, negative 1900, negative 1600, plus Fji in the y, plus Fjc in the y equals 0. 0 up there. Because these two are equal, we can say that oh wait, let's look at this. So 1200 wait, these two, we had gotten negative signs on both of those, which means these were both pointing up. That's the direction they should have gone. So that makes this one a positive and this one a positive. And we get 1200 plus 1900 is negative 300. This would be a positive 1600 minus 1600 would be 0 equals Fji plus Fjc. And so 0 is the answer for those. And that's it.